Hello there, finite students. Okay, today we are going to begin our journey through chapter 6, which is about logic and symbolic logic is usually the way that we describe it. So let's get right into this. We're ready to start section 1. The notes for this section are available on Schoology, and that's what I'm going to be using here. I might have done kind of some different things in class, but if you're kind of following along at home through these videos, we are just going to use these class notes. So you might have your own copy already. That's great. If not, you can get one from online. Okay, let me kind of get things set up here a little bit. Make my face a little bit bigger. Okay, so ready for chapter 6 over logic. So we start off by just kind of identifying that when we are trying to determine whether a large statement is true or false, because that's the goal of this, is determining whether a statement is true or false. We have to start by defining what a statement is, and then eventually we're going to be combining these statements together into bigger statements. Okay, so first of all, a statement is a declarative sentence, and by declarative, I mean that sentence can be validated as either true or false, but not both simultaneously. Now, you might be asking, how can something be both true and false at the same time? We'll see that in a minute. But a statement is a declarative sentence. That means that it is a statement of fact. Now, that statement might end up being determined to be a false statement, right? That people claim things as facts all the time that are later determined to be false, but that doesn't matter. That's still a statement. Okay, if I say my hair is purple, that's a statement. I'm making a claim. That claim might be false, but it's still a claim. That's a statement. So the Oriole is the high school mascot. That's a claim. That's a statement. Yes, that can be determined to be either true or false. 7 + 5 = 10. Well, 7 + 5 = 10. That is not true. However, it is still a statement, right? We are claiming that 7 + 5 = 10. What we're claiming might not be true, but we're still making a claim. And so this is still considered to be a statement. Follow the yellow brick road is not a claim. That's a command. So that's not a statement. Are we having fun yet is a question. That's not a claim. That's not a statement. This sentence here, you might have seen before, the statement is false. Well, that's kind of a claim. Okay, I mean, it kind of is that they're making a claim here that the statement is false, and we might be able to determine, okay, that claim is true or that claim is false. But think about this for a second. If this claim is true, then the statement itself says that it's false then, right? If the sentence is true, then, well, it says it's false. And if we determine that this claim is false, well, then it is false that the statement is false. That would mean it's true. This is called a paradox, and this is what we mean by something that is true and false simultaneously. We're not going to deal with things like that in our logic chapter here. If you just Google paradox, you can find some other cool examples of that. Okay, so we just don't allow statements to refer to themselves. See how this statement refers to itself? It's talking about itself, so that's kind of how you avoid a paradox there. A compound statement is one or more simple statements combined by logical connectives. So if we use the words and or to connect two statements together, we now have created a compound statement. If we negate a statement, meaning we use the word not to change the truth value of the statement to, whatever the opposite of whatever it was, then that's a compound statement. We'll also see statements that are called conditional statements that are written in if-then form, like if it is Tuesday, then we have a gold schedule or something like that, right? That would be an if-then statement. The parts of the compound statement are called the parts of the compound statement are called component statements. So let's start looking at examples of combining statements together. This just asks us to determine whether each of the following is a compound statement. Remember what it means for a statement to be a compound statement. We are joining statements together with and or we throw a not in there, or we put the statement in if-then form. Doesn't matter whether the statement's true or false here. we're just stating whether it's compound or not. So Mrs. Leahy teaches finite math and Mr. Rickard teaches calculus. We got two statements here joined with the word and, so this is indeed a compound statement. If you want a cup of coffee, then you should buy one. There's that if-then form. That's a compound statement. We decided to play a game of truth or dare. Now, I know you see that word or there, and we said if you join statements together using and or, you've got a compound statement. But notice that this or is not joining two component statements together. This or is part of the name of that game. So there is no compound statement here. This is a single claim about a game that we decided to play. That is a simple statement, not a compound statement. Today is not Tuesday. Okay, so like the original claim would be that today is Tuesday. When we throw that not in there, that changes the truth value of the statement to the opposite of what it was before. If it really was Tuesday, now we're saying it's not, right? It means the opposite of what it used to, and we do consider that to be a compound statement. And this is something we call a negation. When we change a true statement into a false statement, or a false statement into a true statement, that's a negation. So a negation is basically the opposite truth of the original statement. The negation of a true statement is false, negation of a false statement is true, and so on. All right, so we're going to give the negation of each of these. I'm not going to write these down, I'm just going to say them. Mrs. Leahy has a 2-year-old son. I need to update these notes so they don't say Mrs. Leahy anymore. I need to make it so they say Mr. Thompson. I don't believe Mrs. Leahy does have a 2-year-old son. She has a son, but I don't think he's 2 years old. Anyways, the negation of that statement would be Mrs. Leahy does not have a 2-year-old son. Easy enough. This coupon cannot be doubled by the retailer. The negation of that would be just the statement of the opposite meaning. This coupon can be doubled by the retailer. Okay, down here we have some more mathematical negations. Like, what's the opposite of x is greater than 8? So instead of using all the numbers bigger than 8, we would use all the numbers less than or equal to 8. That would be the negation. It kind of means everything else. Y is less than or equal to 50. Well, instead of all the numbers less than or equal to 50, the negation of that would be all numbers bigger than 50. There you go. Okay. Now we're going to get into how to use symbols to start joining these statements together. Whenever we want to join statements together using the word and, we call that kind of compound statement a conjunction, and this is our symbol for a conjunction. It's kind of an upside down arrow. Whenever we want to join two statements together using the word or, we call that compound statement a disjunction, and the symbol for that just goes the other way. And it's a little bit tricky to keep these symbols straight, so you might have to do a little bit of work there, kind of working on remembering which statement means and which statement means or. Now, if you want to change the meaning of a statement, if you want to do the negation of a statement, we have a symbol for negation as well, which is just this little like curly symbol like that. Okay, so I've got some of these that I already wrote out in words, and we are representing individual simple statements with a single letter like P or Q, because we don't always want to have to write out all this stuff every single time. What a pain, right? So instead of writing out the tie is black every time, we just represent that statement using the letter P. Instead of writing out the vest is red every time, we just represent that statement with the letter Q. So this statement here would be the tie is black, and now we have a negation, the vest is not red. Okay, you can kind of look through the rest of these. Here I have the tie is not black, or, that should say or, sorry. Or, and then Q means the vest is red. These other two are a little bit tricky to kind of write out in words because we've got the tie is black or the vest is red, and then the negation of that, which kind of means it's not true that either the tie is black or the vest is red. Same thing here, I've got the tie is black and the vest is red, and then we negate that. So it's not true that the tie is black and the vest is red. Okay, so now we get into the idea of a truth table, and I'm going to save that part for the second part of the video over section 6.1. So I'll see you there.